our swap topic today, we are going to deal with power. So, without much ado, we shall look at the learning objectives or the learning outcomes that we're supposed to discuss by the end of this video. So, one, by the end of the video, you should be able to define the term power. You should be in a position to identify the relationship among power, voltage, current, and resistance. And later on, you should be able to perform calculations involving power. So let's start by defining the term power. And power is the rate at which electrical energy is transferred or converted. In other words, you can say that power is the rate at which energy is consumed or delivered. Power is measured using watts, and the measuring instrument that is used to measure power is voltmeter. I believe that is okay with you. So let's look at the second learning outcome, whereby we are going to look at the relationship between power, voltage, and current. Power, voltage, current, and resistance. So the relationship between power, voltage, current, and resistance is described by Ohm's law and the power law in electrical circuits. Remember in our first video, that is electrical quantities, we stated Ohm's law, and we said that Ohm's law states that voltage is directly proportional to current and resistance, holding all other factors constant. So voltage, we said, it is the electrical potential difference between 2 points, or voltage is the supply of energy to an electrical circuit. That is what we said in the previous video. And current is the rate flow of electrons or charge in a circuit. Current is the rate flow. Current is the rate flow of electric charge or electrons in a circuit. And resistance is the opposition to the flow of current. Resistance, it is the opposition to the flow of current. Now let's look at power law. And power law states that power is a product of voltage and current, whereby we had defined what is power, and we said that power is the rate at which electrical energy is transferred or converted, or power is the rate at which electrical energy is delivered or consumed. Power can be expressed in three occasions. One, we can express power in terms of current and resistance. Two, we can also express power in terms of voltage and resistance. And also, we can also express power in terms of voltage and current. So, when you talk about expressing power in terms of voltage and current, is using power law, whereby we say that power is given by voltage times current. So, in a scenario whereby you are given voltage and current and asked to determine power, you'll take the product of voltage and current, and what you'll get there will be power. We can express power in terms of current and resistance. Therefore, power is given by current squared multiplied by resistance. Power is given by current squared multiplied by resistance. In terms of voltage and resistance, power is given by voltage squared over resistance. Power is given by voltage squared over resistance. We shall perform calculations using those three formulas, so don't worry, and I know it will be simple for you and you'll understand what we are saying when we talk about those three expressions. So we can remind ourselves, we said power is measured in watts, and power we have said is the rate at which energy is consumed or delivered. Current is measured in amperes, and voltage is measured in volts. This one we discussed in video 1, that is electrical quantities. Now let's go direct to look at the power triangle. I know this one is not new for you, this triangle. We have talked about it, or we have discussed about it while we were looking at charge. So we say that this line means division, while this line here means multiplication. So if you're looking for power, power will be given by current multiplied by voltage. When you're looking about current, we shall have power divided by voltage. When we're looking about voltage, we shall voltage will be given by power divided by current. Let's look at our learning outcome number 4. That is performing calculations involving power. Let's look at example 1. Remember, you can pause the video and try to figure out what we are talking about. So calculate the power that passes through a lamp if its current is 1.5 amperes and the supply voltage is 9 volts. Calculate power that passes through a lamp if its current is 1.5 amperes and the supply voltage is 9 volts. Remember, we have seen that power can be expressed in three ways, whereby we can express power using voltage and current. We can also express power using resistance and current. We can also express power using voltage and resistance. In this scenario, we are going to express power using current and voltage because it's what we are having here. We are having voltage here and we are having a current and we are having voltage. And we have said that power is given by current multiplied by voltage, or voltage multiplied by current. So when you take your calculator and key in 1.5 multiplied by 9, power you will get as 13.5 watts. You can write in full or abbreviate it as capital W. No one will penalize you. So power will be given by 1.5 multiplied by 9, and therefore our power will be 13.5 watts. You can pause the video and perform the calculations. Let's look at our example 2. And example 2 says, if the supply voltage in an electrical circuit is 240 volts and the power consumed is 20 kilowatts, what is the current flowing in that particular circuit? The supply voltage in an electrical circuit is 240 volts and the power consumed is 20 kilowatts. What is the current flowing in that particular circuit? So this question is asking us about current, and we can see that we are having power, which is 20 kilowatts, and we're having voltage. So using our power triangle, we can say that current is given by power divided by voltage. Current is given by power divided by voltage. Remember, the word kilo means 1,000. Therefore, our power is 20,000 watts. Therefore, we shall have 20 multiplied by 1,000. Then we divide by our supply voltage, which is 240 volts. So when you take your calculator and key in 20 times 1,000, 20 times 1,000 divided by 240. 20 times 1,000 divided by 240. Our answer will be 83.333 amperes. Always remember to write your answer into 4 decimal places. Always remember to write your answer into 4 decimal places. And don't forget to write the SI unit for that quantity which is asked. Our case is asking here current. Therefore, we know that the SI unit for current is amperes and it is abbreviated as capital A. I believe it's clear. If it's not clear, kindly comment on this comment section, and I know I will respond to that. Or when we have a physical class, you can as well raise your concern. Example 3. Assuming that power consumed by Kahindi Enterprise is 1.5 kilowatts and the current flowing through the equipment is 80 amperes. Calculate the supply voltage required in Kahindi's enterprise. So here we are being asked to calculate what? Voltage, whereby we have been given power in kilowatts and we have current in amperes. Therefore, remember, using our power triangle, voltage is given by power divided by current. Voltage is given by power divided by current. Therefore, our power is given in kilowatts, sorry. So we shall take 1.5 multiplied by 1,000. Remember, I have said that kilo means 1,000. So we shall have 1,500. Then that is our power in watts. Our power in watts is 1,500. So we shall divide by current, and our current is 80 amperes. So when you divide 1,500 over 80, we are going to get 18.75 volts. 18.75 volts. I believe it's clear. So we have seen how to use the power triangle to calculate power, current, and voltage. Now let's look at how to calculate power using either the current and resistance expression or the voltage and resistance expression. So in our example 4, we are given that the resistance of a wire is 0.25 ohms and the supply voltage is 230 volts. Determine Roman 1 the current flowing through the wire, and Roman 2, the power dissipated in that particular circuit. So the first thing we shall do is to look for current. We are we have resistance and we have voltage. So we shall use Ohm's law to look for current. And we know that current in Ohm's law is given by voltage over resistance. Current in Ohm's law is given by voltage all over resistance. Our voltage is 230, sorry. Our voltage is 230 volts divided by 0.25 ohms. And we shall be having our current as 920 amperes. That is part 1. I believe it's clear. So let's look at part 2, whereby we are going to solve for power dissipated in that particular circuit. We know that power is given by current multiplied by voltage. And we have seen our current was 920 amperes and our voltage was 230. Therefore, we shall have 920 multiplied by 230 volts for us to get power. And we are getting 211,600 watts. We are getting 211,600 watts. You can write in this in watts, or you can divide by 1,000 and say your answer will be 211.6 kilowatts. 211.6 kilowatts. So remember, my class cannot end without an assignment, and I will give an assignment for you. A resistance, a resistor with a resistance of 8 ohms has a current of 3 amperes flowing through it. What is power dissipated by that particular resistance? So here you are having resistance and you are having current. So which expression are you going to use for you to be able to calculate that? You have two ways. One, you can use the expression for power is given by I squared or current squared multiplied by resistance, or you can look for voltage because you have amperes and ohms. You have current and resistance, you can look for voltage. Then after getting voltage, which will be 3 multiplied by 8, you'll have 24, and 24 will be your volts. And we know that power is given by voltage multiplied by current. Therefore, we shall have 24 multiplied by 3, and your answer will be 72 watts. The other way, you can as well say power is given by current squared multiplied by resistance. Our current squared is 3 squared will be 3 squared will give us 9 multiplied by 8, and it will give us the same answer, which is 72 watts. So kindly perform the other calculations. We have done exam assignment 1 with you. So kindly do assignment 1, assignment 2 and 3. Remember also to write assignment 1 in your exercise books or your writing materials. So assignment 2 says that a heating element has a resistance of 15 ohms and is connected to a 240 volts power supply. What is the power consumed by the heating element? So they need power here. You have voltage and you have ohms. Remember, you can use the power triangle whereby you look for current, then you look take current multiplied by voltage, or you can say that power is given by voltage squared divided by resistance. Assignment 3. A circuit has a voltage of 50 volts and a power consumption of 200 watts. What is the resistance of the circuit? So here you have voltage and you have watts. They are asking for resistance. You can use the same formulas as example 2, as in assignment 2. But kindly perform this assignment and I will confirm them in our previous lesson, in our next lesson. So if there is any concern, kindly raise it in the comment section. So that is the end of our session. May God bless you and may you have a nice evening. Thank you for watching.